Good morning, dear students. How are you? I hope all are fine. Okay, today our concept is De-Broglie's wave theory. What is the importance of De-Broglie wave theory? Let me explain now. We know that electron has both wave nature and particle nature. The wave nature of electron was first explained by De-Broglie. According to De-Broglie theory, all moving particles have wave properties. Wave properties are important only for particles of small mass and high velocity. Now let me derive equation for the De-Broglie's wave theory. From Planck's quantum theory, E is equal to h mu. We know that C is equal to mu lambda. From this, if you write the mu value, then we get mu is equal to C by lambda. Now we have to substitute this mu value in E is equal to h mu. Then we get hc by lambda. It means E is equal to h mu, that is equal to hc by lambda. This is equation number 1. Now from Einstein's mass energy relationship, E is equal to mc square. Now let me say this is equation number 2. So from equation 1 and 2, both are energies. That is also energy, this is also energy. Now let me equate these two energies. Then we get hc by lambda is equal to mc square. So if you cancel the both c's, then we get lambda is equal to h by mc, where c is the velocity of light. If the velocity of microparticle is v, then De-Broglie's equation is lambda is equal to h by mv. In the place of c, we wrote just v. We know that momentum p is equal to mv. So in the place of mv, let me write p, where lambda is equal to wavelength, h is equal to Planck's constant. Its value is 6.625 into 10 to the power of minus 34 joule second. V is equal to velocity of particle, p is equal to momentum of the particle. So this is the expression for De-Broglie's wave theory. The final expression is lambda is equal to h by p. Now let me verify whether the De-Broglie's wave concept is related to the Bohr's theory or not. So first let me take two possibilities of moving of electrons around the nucleus in a orbit. So here two types of waves are possible for an electron moving around the nucleus in the circular path. First possibility is a standing or stationary or non-energy radiating wave. Second possibility is non-stationary or non-energy radiating or non-standing wave. Now first let me explain about first possibility, that is a standing or stationary or non-energy radiating wave. So in this possibility, electron is revolving around the nucleus in a fixed energy shell as like a wave. The initial point and final point both are meeting. For this possibility, if you calculate the circumference of the circle, it means 2 pi r, it must be equal to the integral multiple of wavelengths. It means n lambda, that is 2 pi r is equal to n lambda. From this, lambda is equal to 2 pi r by n. Here n is equal to integer or whole number. We know that lambda is equal to h by mv from De-Broglie's wave theory. In the place of lambda, I wrote 2 pi r by n. So 2 pi r by n is equal to h by mv. From this, mvr is equal to nh by 2 pi. So this mvr is equal to nh by 2 pi is the quantization condition for the electron in Bohr's theory. Hence, De-Broglie's theory and Bohr's theory are agreement with each other. Now let me explain second possibility, that is non-stationary or non-energy radiating wave. In this, electron is revolving around the nucleus in a fixed energy shell, but the initial and final points both are not meeting. For this possibility, the circumference 2 pi r is not equal to n lambda. Hence, such an orbit cannot exist. So, from this we have to conclude that the first possibility is correct for an electron. Now let me explain about De-Broglie's applications. First one, to calculate the number of waves in an orbit, the formula is n. So what is the shell value that many waves can produce in that shell? Second application is number of revolutions of an electron per second in an orbit is equal to velocity of electron by circumference. Now third application is relation between kinetic energy and wavelength of a moving particle, that is lambda is equal to h by root over 2 KEM. Now let me derive that relation. We know that kinetic energy is equal to half mv square. Divide and multiply with m, then we get kinetic energy is equal to half mv square into m by m, that is equal to half mv whole square into 1 by m. We know that mv is equal to momentum. In the place of mv, now let me write p, then we get kinetic energy is equal to p square by 2m. From this I want p value, then we get p is equal to root over 2 KEM. From the De-Broglie's wave theory, lambda is equal to h by p. Now substitute p value in this equation, then we get lambda is equal to h by root over 2 KEM. This is the relation between kinetic energy and wavelength of a moving particle. This is for one particle. If you want for two particles, then the expression we get like lambda 1 by lambda 2 is equal to root over ke2 by ke1. Now the fourth application is let a charged particle like electron be accelerated with a potential of v, then kinetic energy is equal to E into v. From this we have to write lambda value h by root over 2 ev into m. Simply we substituted in the place of ke ev. If you substitute h value and charge of the electron and mass of the electron in the above formula, then we get lambda is equal to 12.27 by root v Armstrongs. ORR, we have to write this expression like root over 150 by v ORR 1.23 by root v nanometers. Now the fourth application is if you substitute v value also, then we get the De-Broglie wavelength of an electron in a given orbit is equal to 3.33 into n Armstrongs. Okay dear students, now let me explain some problems regarding De-Broglie's wave theory. Okay, first problem is the De-Broglie wavelength of a tennis ball of mass 60 grams moving with a velocity of 10 meters per second is approximately. Okay, now let me do the answer. Given that mass of the tennis ball is equal to 60 grams, they gave in grams, so we have to convert into kilograms. So we have to multiply with 10 to the power of minus 3, then it will convert into grams. Then it became 60 into 10 to the power of minus 3 kgs. In the question they gave velocity 10 meters per second. Now we know that lambda is equal to h by mv according to De-Broglie's wave theory. Now we have to substitute all the given values in the above formula. Then we know the Planck's constant H value 6.625 into 10 to the power of minus 34 joule second. So lambda is equal to 6.625 into 10 to the power of minus 34 joule second by 60 into 10 to the power of minus 3 kg into 10 meters per second. This is very important conversation. That is, in the place of joules we have to substitute kg meter square per second square. Now in the place of joules, now we have to substitute kilogram meter square per second square. Then we get kg cancel, meter cancel, second cancel, here also second cancel. Then finally we got the answer 10 to the power of minus 33 meters. Next problem is the wavelength of moving electron having 4.55 into 10 to the power of minus 25 joules of kinetic energy is. Now let me do the answer. Given that kinetic energy Ke is equal to 4.55 into 10 to the power of minus 25 joules, we know that mass of the electron is equal to 9.1 into 10 to the power of minus 31 kgs. We know the formula lambda is equal to h by root over 2 KEM according to De-Broglie's wave theory. Now we have to substitute all the above values in this formula. Then we get 6.6 into 10 to the power of minus 34 joule second by root over 2 into 4.55 into 10 to the power of minus 25 joules into 9.1 into 10 to the power of minus 31 kgs. If you do the calculations, finally we get the answer 7.4 into 10 to the power of minus 7 meters. Next problem, calculate the wavelength in nanometers associated with a proton moving at 1 into 10 to the power 3 meters second inverse. Mass of the proton is equal to 1.67 10 to the power of minus 27 kg and h is equal to 6.63 into 10 to the power of minus 34 joules. Now let me do the answer. Given that proton velocity is equal to 10 to the power of 3 meters second inverse. Proton mass is equal to 1.67 into 10 to the power of minus 27 kgs. H value is equal to 6.63 into 10 to the power of minus 34 joule second. If you substitute all the above values in this formula, lambda is equal to h by mv according to De-Broglie's wave theory concept, then we get 6.63 into 10 to the power of minus 34 joule second actually. But this is very important conversation. That is, in the place of joules we have to substitute kg meter square per second square. Then finally we get answer 0.39 nanometers. It is approximately equal to 0.4 nanometers. Now the next problem is the de Broglie wavelength of a particle with mass 1 gram and velocity 100 meter per second is. Now let me do the answer. Given that mass of a particle is equal to 1 gram, if you convert into kgs, then 1 into 10 to the power of minus 3 kg. Velocity v is equal to 100 meter per second. Now lambda is equal to h by mv. If we substitute all the above values in this formula, then we get answer, that is lambda is equal to 6.625 into 10 to the power of minus 33 meters. Now the next problem is, if wavelength of photon is 2.2 into 10 to the power of minus 11 meters, h value is equal to 6.6 into 10 to the power of minus 34 joule second. The moment of photon is, now let me do the answer. Given that wavelength lambda of photon is equal to 2.2 into 10 to the power of minus 11 meters, h value is equal to 6.6 into 10 to the power of minus 34 joule second. Now we have to calculate the momentum. We know that lambda is equal to h by mv, that is equal to h by p. So we want p, then p is equal to h by lambda. Now we have to substitute all above values in this formula, then we get answer p is equal to 3 into 10 to the power of minus 23 kg meter second inverse. Now the next problem is, if the Planck's constant h is equal to 6.6 into 10 to the power of minus 34 joule second, the De-Broglie wavelength of a particle having momentum of 3.3 into 10 to the power of minus 24 kg meter second inverse will be. Now given that h is equal to 6.6 into 10 to the power of minus 34 joule second, p is equal to momentum, that is equal to 3.3 into 10 to the power of minus 24 kg meter second inverse. Now we have to calculate the lambda value. Lambda is equal to h by p from the De-Broglie's wave theory. Now we have to substitute all the values in this formula, then we get answer 2 into 10 to the power of minus 10 meters. We know that 10 to the power of minus 10 meters is nothing but 1 Armstrong. Then finally we get answer lambda is equal to 2 Armstrongs. Now the next problem is, the De-Broglie wavelength of an electron in the ground state of hydrogen atom is. Now let me do the answer. First let me write the values which are given in the question. Now all these values we have to substitute in this formula, then we get answer. Now the next problem is, the mass of a photon with a wavelength equal to 1.54 into 10 to the power of minus 8 centimeters is. Now let me do the answer. First let me write the values which are given in the question. Now all these values we have to substitute in this formula, then we get answer. Now the next problem is, the De-Broglie wavelength associated with a ball of mass 200 grams and moving at a speed of 5 meters per hour is of the order of, h value is given 6.625 into 10 to the power of minus 34 joule second. Now let me do the answer. First let me write the values which are given in the question. Now all these values we have to substitute in this formula, then we get answer. Now the next problem is, if a photon and alpha particle are accelerated with the same kinetic energy, the ratio of De-Broglie wavelengths lambda p and lambda alpha is. Now let me do the answer. First let me write the values which are given in the question. Now all these values we have to substitute in this formula, then we get answer. Now the next problem is, if the De-Broglie wavelength of a particle of a mass m is 100 times its velocity, then its value in terms of mass and Planck's constant is. Now let me do the answer. First let me write the values which are given in the question. Now all these values we have to substitute in this formula, then we get answer. Now the next problem is, a 0.66 kg ball is moving with a speed of 100 meters per second. The associated velocity will be. Now let me do the answer. First let me write the values which are given in the question. Now all these values we have to substitute in this formula, then we get answer. Now the next problem is, what will be the De-Broglie wavelength in meters of an electron moving with a velocity of 1.2 into 10 to the power of 5 meters second inverse. Now let me do the answer. First let me write the values which are given in the question. Now all these values we have to substitute in this formula, then we get answer. Now the next problem is, calculate De-Broglie wavelength of an electron traveling at 1% of the speed of the light m. Now let me do the answer. First let me write the values which are given in the question. Now all these values we have to substitute in this formula, then we get answer. Now the next problem is, what is the wavelength associated with an electron moving with a velocity of 10 to the power of 6 meter per second, given h is equal to 6.63 into 10 to the power of minus 34 joule second and mass is equal to 9.1 into 10 to the power of minus 31 kg. Now let me do the answer. First let me write the values which are given in the question. Now all these values we have to substitute in this formula, then we get answer. Now the next problem is, the wavelength of electron waves in two orbits is 3:5. The ratio of kinetic energy of electron will. Now let me do the answer. First let me write the values which are given in the question. Now all these values we have to substitute in this formula, then we get answer. Now the next problem is, lithium and a proton are accelerated by the same potential. Their De-Broglie wavelengths lambda Li plus 3 and lambda p have the ratio. Assume mLi, I mean mass of lithium, is equal to 9 into mass of proton. Now let me do the answer. First let me write the values which are given in the question. Now all these values we have to substitute in this formula, then we get answer. Now the next problem is, an electron has kinetic energy 2.8 into 10 to the power of minus 23 joules. De-Broglie wavelength will be nearly. Now let me do the answer. First let me write the values which are given in the question. Now all these values we have to substitute in this formula, then we get answer. Now the next problem is, the De-Broglie wavelength of an electron accelerated by an electric field of V volts is given by. Now let me do the answer. First let me write the values which are given in the question. Now all these values we have to substitute in this formula, then we get answer. Now the next problem is, if the wavelength of an electron is numerically equal to the distance travelled by it in 1 second, then. Now let me do the answer. First let me write the values which are given in the question. Now all these values we have to substitute in this formula, then we get answer. Now the next problem is, if a photon and alpha particle are accelerated through the same potential difference, the ratio of De-Broglie wavelengths lambda p and lambda alpha is. Now let me do the answer. First let me write the values which are given in the question. Now all these values we have to substitute in this formula, then we get answer.